So I actually want to walk through this from the beginning. I know you just had a question on part B, but it's more important that you understand the entire process so you can kind of see how part B is related to part A. So we're going to do part A again from scratch, just so you can understand that process, and then you can kind of see how part B is going to feed into that process. So here's the issue. You're driving down the highway late one night, 20 meters per second, when a deer steps onto the road 35 meters in front of you. So you're here, the deer is here, and we know that this is 35 meters. Now what happens is your reaction time before stepping on the brake. So we're going at 20 meters per second here. And we do not hit the brake immediately, right? Like at some point later, now we hit the brake. So during this time from here to here, we'll call this the time that, you know, we're not braking. We're going 20 meters per second the entire time, okay? And then we step on the brakes, and from here to here, and then our acceleration becomes, 10 meters per second squared to slow down. So this motion from here to here takes 0.5 seconds. And then the motion from here to, we're not going to hit the deer, because the question is how much distance between you and the deer when you come to a stop. So at some point, we stop somewhere else where the final velocity is zero here, or the velocity is zero and we have the acceleration here. So the issue, here's the problem. The problem is our kinematic equations only apply when the acceleration is constant. And during this part of the motion, the first part, the acceleration is zero. Then during the second part, the acceleration is non-zero. It's going to the left because we're slowing down. So we cannot use the kinematic equations over the entire range, the entire interval of the motion. We have to do it separately over each part of the motion. This is motion 1, this is motion 2. Okay, so from here to here, so when we're going to talk about this, we're going to talk about what's the motion from there to there. This one's a lot easier because when the acceleration is zero, the kinematics is actually mostly simple. We know the time 0.5, we know the initial velocity is 20, we know it end at 20, and we want to know like what distance this is. Why do I want to know the distance? Because I want to know overall how far we traveled to get to this point here. And we know, again, like this entire distance is 35 meters. Okay. So that's the main idea on the setup we want to do here. So how do we find that? We're just going to use this equation. It doesn't really matter which equation you use. This is the most simple equation that relates these variables. But when the acceleration is zero, then this term just goes away. Because if I plug in a equals 0 into there, it's just going to vanish to 0. So you just simply do 20 times 0.5 and you get 10 meters. So this motion from here to here was 10 meters. Okay. Let's do the second half of the motion. Okay. And again, you can't do it over the entire motion because the acceleration is varying. Right at this point here, the acceleration switches. So we have to start over again with a new process like this. Again, I want to know the displacement. The initial velocity is to the right. Let's say right is the positive direction. So it's 20. What's the velocity at the end of the motion? 0, because we come to a stop. What's the acceleration? Negative 10, because the acceleration to the left, and left is the negative direction. And we're not given the time. So what equation relates these four variables, right, would be this. So that 0 squared is 20 squared plus 2 times negative 10 times delta x. And then we solve for delta x here. So we're going to get 20 squared divided by 20. I get 20 meters here. So the second motion here, we traverse 20 meters. And so that means it's been 30 meters. That means the remaining distance is 5 meters here. Okay, so we stop 5 meters before the deer. Okay. Now part B, we just simply want to reframe everything we did, but now it's what is the maximum speed you could have and still not hit the deer. So ultimately, we want to reverse engineer what we did, except now we're saying it's not 20 anymore. It's some other value that we don't know. And that's what we're trying to figure out. We'll call it some velocity. We'll just call it V. I just give it a letter. But we'll just call it V0. I don't know, whatever you want to call it, okay? V0. Okay, this is what I want to know. So let's go back, and we're going to backtrace everything that's true. So all the 20s we're going to replace with V0. Okay, so let's erase this, V0, V0, V0. And there's two distances here. Let's call this, say, D1, and we'll call this D2. And we know that D1 plus D2, the total distance has to add to 35 meters. So we'll call this D1, and we'll call this D2. And again, we want to relate everything that we just did. We want to relate the distance here for this motion is D1 is equal to V0 times 0.5. And then same equation here. What relates these equations? Same thing, we're going to get 0 squared. This same equation here is going to be V0 squared plus 2 times negative 10 times D2. And then we want to use this fact as well. So if we know what D1 is, we're going to solve for D2 and plug that into here. And we're going to set equal to 35. So 0 is equal to V0 squared minus 20 D2. That means 20 D2 is equal to V0 squared. And then that means D2 is equal to V0 squared over 20. Okay, so we have D1 and D2. Those are the distances. They're expressions now. They're not quantities we solve for. They're expressions, but it's still the same idea. I want to add those together, and that has to add to equal 35. Okay, so how are we going to solve this? It's a V0, V0 squared. It's a quadratic. Like, you can write this 1 over 20 as 0.05 V0 squared. Oops, put a plus sign there. Equals 35. So then you're just going to set it equal to 0. So you're going to do 0.05 V0 squared plus 0.5 V0 minus 35 equals 0. And then we use quadratic formula, use factoring, however you want. That's how you would solve this. So V0 would be negative B, like this is B, plus or minus square root of B squared minus 4 times A times C divided by 2 times A. Oops, 0.5. And it doesn't matter. I mean, at this point, it's a math problem. You're going to get two answers. The one that's positive is the one that's going to make sense. Because negative would mean it's like going to the left. And that's not really like, it doesn't really make sense to talk about it that sense. So it's just going to be just the positive value that we're going to get there. And that's it. So you kind of see the process always the same. We have to draw that motion. We just have to establish what the variables are and, picking the right kinematic equations. But the key thing is that we can only do the kinematic equations over a period of interval where the acceleration is constant. If the acceleration ever changes, we have to cut it. That's the end of an interval, and we have to start a new interval for that different motion. So hope that makes sense.